Problem number 2 of page 15. A breeding program to ensure the survival of pygmy possums is established with an initial population of 50, 25 pairs. From a previous program, the expected population p subscript n in n years' time is given by p subscript n equals p sub 0 times 2 to the 0.3 n power. What is the value of p subscript 0? Okay, so p subscript 0, if you remember from the investigation, is a multiplier times the exponent. The exponential function, the exponential expression, if you have the time, which is the initial time of n equals 0, if you put that in the exponent, 2 to the 0 is 1. So the initial value is always going to be this multiplier here. And in this case, we know that the initial population is 50. Okay, so p subscript 0 should be 50. Okay, so our expression becomes p subscript n equals 50 times 2 to the 0.3 n power, n being the years. So I'm going to put in the calculator in the y equals screen, I'm going to put the expression 50 times 2 to the 0.3 power, 0.3 n power. And we don't have n, we just have x, so we're going to put x as the variable. And then I could graph it, or I could look at it in the table format. In this case, since it asks us for specific values, it's better to look at it in the table format. So we're going to do second table. And I have several values here. The first value at x equals 0 or n equals 0, 0 years, the number of possums is 50. And let's see, after 2 years, that would be n equals 2, it's at 75.786. We could round that to 76. After 5 years, it's at 141.42. We could round that to 141. I'm just rounding it because the number of expected possums cannot be it should be a whole number, right? And after 10 years, it'll be 400. Okay. Then it says to sketch the graph of p subscript n, which is the population at year n, against n using a and b only. So I'm just going to use these points. Basically, I'm going to have, my first point is going to be n equals 0. Population is 50. The next one is going to be 2, 76. The next one is going to be 5, 141. And the next one is going to be 10, 400. So I'm going to graph these here. I have from 0 to 10, so I'm going to put 0 here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 10. Okay, so this is years. And then on the y-axis, I'm going to put the number of possums. So it's going to be 100, 200, 300, 400. 200. Okay. So in the first year I have 50, so that would be this point here. In year 2 I have 76. Year 2 would be here. 76 would be about here. Year 5 I have 141. That would be about here. And year 10 I have 400. It's about here. So now I can connect those in a exponential curve, about like that. It said to only use those 4 points. D, use technology to graph y equals 50 times 2 to the 0.3x and check your answers to B. So actually we already used the calculator to calculate these values. So graph. Oh, it's too high. So the first thing you're going to do with zoom normally is to do zoom standard, but these numbers are so big that zoom standard, which goes from -10 to 10, is way too small. So let's try to capture all the y interval that that this function goes through, and the way we do that is we do a zoom fit, enter, and it's going to adjust the y scale so that we can see the whole function along this interval of -10 to 10. And if you want to check the values here, you could either do second table like we did before, or you could do trace, which is that one. And then we could, like, when you first click on trace, it goes to x equals 0 to see y equals 50. We confirmed that it's 0, 50. We could go to 2. We could just type 2, enter, and it'll go to x equals 2, y equals 76, right? We could do trace and then hit 5. Oops. Graph, trace, 5, and it'll go to 5, 141. And last of all, we'll go to 10. We'll go trace, 10, and it'll go to y equals 400. So we've confirmed all the values there. All right, so that's how you use the calculator both in table mode and graph mode to see where the curve is going.